This is just a short video to talk a little bit about a stereo system I made a couple of years ago. Basically, I wanted to actually buy the best stereo I could, and I was willing to spend a few $1,000s buying something awesome. But it turns out that when I went to the store, all the stuff I liked was like 50, 60, 70,000 bucks. And I figured, well, maybe I could just make my own stereo system. And one of the things that I found when I was shopping for the high-end stuff was this active speaker design, where there's a separate amplifier driving each channel, the tweeter or the mid-range or the woofer. And I really appreciated all the benefits of this active design with respect to amplifier utilization and avoiding passive crossovers and all these details that you can look on the internet and find out all kinds of things about. So what I came up with was this actually kind of, and I didn't want to spend a lot of money, so I came up with this relatively unique solution of using a cheap audio-visual amplifier, which you see right here. I use a $200 Sony amplifier, and I use a laptop to actually take the audio signal and to spectrally separate it into the three channels, the three spectral channels, the tweeter, the mid-range, and the woofer, and then I route that over HDMI into the AVR. So this is actually a fantastically cheap way to get a fully active speaker design and have complete control over the digital crossovers for all the drivers. I'll just talk a little bit about the process of how I came to realize this particular architecture, how it works in the laptop to get the signal out over the HDMI, the 6 channels, the woofer, the tweeter, and the mid-range for the left and right channels. And also a bit about the amplifier testing I did, because most people, they really wouldn't want to use a $200 amplifier for a relatively high-end audio system. But I did a bunch of objective testing on this in the lab and with some listeners, and came to the conclusion that this $200 amplifier actually is not a problem.
So I did some very careful amplifier testing with various listeners. And then I carefully studied the power in music and did some power testing on the amplifier. So then I took the raw digital music information and I imported it into a computer software program so I could spectrally decompose it and do some signal analysis on the powers in the signal, so I could make some determinations or some investigation of whether the amplifier was going to be able to deal with this properly and at the full sound pressures and volumes that I was interested in. It was very interesting. It's interesting to see where the spectral energy in the sound is, and everything worked out well.
So here's a bit of a block diagram about how this is implemented. I take all the sound in the OSX environment and I route it through Soundflower, and Soundflower is a program you can get on the internet for free. And then from Soundflower, I route it all into an aggregate device and then use Audiolab. I think it's an AU Lab actually, which is a OSX developer tool, I think, to then separate it and assign it to the HDMI channels. It's pretty simple and it's pretty awesome. And in this AU Lab environment, you can apply audio units in series with the signal stream and add whatever effects you want. Now Apple's got a bunch that come native with Audio Lab, but I also found this other person on the internet that had made some special crossover audio units that I use. I use a mix of the Apple stuff and the crossover audio units that I found on the internet, and it just outputs it over the HDMI. So it's pretty simple. Any sound that would normally come out of the speakers on my laptop now gets routed through this process and comes out spectrally separated to the active speaker system.
So then I built some speakers, and we took the speakers into an anechoic chamber to tune the digital crossovers for essentially flat frequency response in this particular first pass. The speakers are a video of themselves, and I'll talk about their design later because they're a pretty unique approach in their own right. This is a quick demonstration how I can switch the various channels on and off while the music's actually playing.
Moi, je t'affilie des balles de pluie. Il ne pleut pas. Je creuserai la terre jusqu'après ma mort pour couvrir ton corps d'or et de lumière. Je ferai un...
So here's just a little example about what can be done with the user interface. Here we have the iTunes. It's playing a Dave Brubeck song here. And it's fed in here to the main channel of the mixing board bus. And then each of these output channels drives a set of the drivers, and I have a whole crossover detail right in here of different ways the crossovers can work. So just for example, in the tweeter, I can set the frequency, it's Linkwitz-Riley, fourth order, and I can move the frequency around and invert and not invert. And I can do this over a wide range of things, notch filters, lift filters, everything. It's completely flexible in making whatever kind of crossover you want. And of course I can change that on the fly, so I'll just kind of be quiet here and show a couple of things that can be done with this environment. And of course this is a screen share from the computer that's by the window that you can see there. I'm just sharing the screen so I can operate that computer in a place where I can sit and hear the sound in a good way. So let me give you just a little bit of an example of what can be done here. Turn it up a bit so it sounds good. First of all, I can isolate the channels. That's just the tweeter. That's nothing. That's just the subwoofer that you probably can't hear. And that's just the mid-range. We put them all together, we get this pretty powerful combination. And another example of what can be done here. I mean, it's pretty cool. I can vary the gains of all these channels overall. That doesn't sound very good. Down to nothing. Put it up a little bit. Oh, it sounds great. So in part 2 of this video, or of this series, I'm going to talk about the actual design of the speakers themselves. And the design of the speakers have everything to do with how they radiate the sound throughout their spectral frequency range. And this video I'm going to leave you with right here is just an example of switching back and forth on the left channel between a box speaker and the more omnidirectional design. And I'm just going to leave you with this so you can listen to it and you can hear, and you can see if you can hear the difference between the sound between each one, because it's a distinctive characteristic. I'm not going to tell you which is which, but maybe you can pick it out.